Hey, hello and welcome to today's GFG problem of the day. Hope you are doing well. So let's say today's problem level order traversal. So we will be given a root of a binary tree. Okay, we'll be given a root of a binary tree. Okay, and what we want to do is we want to find the level order traversal, the level order traversal of this tree. Okay, now what is a level order traversal? Level order traversal is nothing but breadth first traversal. So in terms of tree, right? So there are two ways or there are two algorithms to traverse the complete tree, right? To traverse the complete tree, one is breadth first traversal and another one is depth first traversal. Okay, so we are going to look at this, right? Breadth-first traversal. Now, what we want to do in this is we want to also what breadth-first traversal is known as. It is known as level order traversal. Now, when we say level order traversal, what it is? So it is traversing the tree level by level. Okay, level by level. So there are three levels here. So what the expected output is, for example, the expected output is result, and we want to do the level order traversal of the tree and insert the elements in the result. For example, so first we go to the first level, so it is 10, right? Then we go to the next level, that is second level. From second level, we have two elements, 20 and 30, and then in the third, we have 40 and 60. Okay, so this is the expected output. Okay, this is the level order traversal. Okay, so we traverse level by level, right? And we add the elements accordingly. Okay, so when it is breadth first traversal or level order traversal, the data structure we use is Q. Okay, Q data structure we use. Now let's see how we'll use this, right? So for example, we have a Q data structure now. So the very first thing what we do is we ingest the root node in the queue. Okay. So we have ingested the root node. Now we are going to run a while loop. Okay. And the while loop will run that till the queue is not empty. Okay. Till the queue is not empty. So what are you going to do? Okay. So we have come into the while loop now. And what we're going to do, the first thing we're going to do is going to pop out the first element. Okay. So what is the first element? It is 10. Okay. And when once we pop out any element from the queue, we are going to add in the result as well. Okay. So we have added this into result. Now here we are going to check. Okay. If it has left child or not. So here, right? So if it has left child or not, yes, it has left child. So we're going to add in the queue. Okay. Again, we're going to check right child or not. Yes, it is there. So we're going to add in the queue. Okay. So we have added, okay, left and right child of 10. Okay. Now, so it is done. This is popped out already. This was popped out already from the queue, right? Now we'll pop out the next element, that is 20. Okay. So 20, we're also going to add in the, we're going to also add in the result. Okay. Now we're going to check whether 20 has left child or not. Yes, it has left child. So we are going to add, right? 40. Also, we're going to check whether it has right child or not. Yes, we're going to add right child as well. Okay. So yes, we are done processing 20 now. Okay. Now we are going to pop out. We are going to check whether queue is empty or not. No, it is not empty. So we are going to pop out the next element or whatever is the first element, right? So we popped out 30. Sorry. So we're also going to add 13 to the result, right? Now we're going to check whether it has left child or not. No, it does not have left child. It neither has right child. So we are not going to add anything. Okay. So now the thing is we have processed 30. Now we're going to pop out 40. Once we have popped out 40, we're going to add it to the result, right? And then we are going to check whether it has left child or right child. No, it does not have. So we won't do anything, right? We are going to then next pop out 60. Okay, we have 60 here. We are going to add in the result 60. We do not have left child and right child, so we are not going to do anything. Okay, so this is the level order traversal which we have got and which is expectation. Okay. Okay, now quickly let's go to the code. I'll do the Java code followed by C++. I'll show the C++ code. Before that, I'll request you to subscribe to my channel. Okay, and like the video. Thank you so much. So let's quickly implement this array list. We have integer result, for example, right? Array list. Then we have Q data structure, right? Q data structure. We have type node. Okay, linked list in terms of Java. Okay, then what we have here? So we are going to add the very first element, as I said, root, right? Root. That is the 10, right? That is this 10. We have added in the queue. Okay. We have added in the queue. Now we are going to run a while loop, right? Queue is not empty. The queue is not empty. Then we are going to pop out the element from the queue, the first element from the queue. Okay. Now we are also going to add into the result, right? End dot data we have added. Now what we're going to do, we are going to check if it has left child or not. Yes, if it has, then we are going to add in the queue, end dot left, right? Similarly, we're going to check for the right child as well. Okay, right, we have added, right? And finally, we're going to return the result. Okay, let's submit. Yes, the solution seems to be accepted. Let's quickly see the C++ code as well. Same, so we have here Q, right? Q data structure we have, and we are pushing the root into the queue. Then we have this vector as a resultant array. Now we are running the while loop till Q is not empty. We have popped out the first element using Q dot front, right? And then we are removing that, popping out the element as well. right? And then we are adding to the result, and then we are checking it, right? Whether it has left child or not. If it has, we are pushing the queue. And then for the right child as well, we are pushing the queue if it is present. Okay, then finally we are returning the result. Okay, so yeah, so these are the Java and C++ solutions I have got. I hope you've got the solution. Thanks for watching. Have a happy, healthy, and a great day. Thank you so much.